Okay. Right. So we are starting with question number 6. So it reads that a long distance bus conductor claims that at least 25% of passengers buy some bananas to eat before reaching their destination. If 18%, if 18 out of a random sample of 60 passengers bought bananas during their trip with the bus, is the conductor right or wrong? You use 5% less of what significant. So we are going to test this hypothesis. And I said yesterday, whenever you're testing the hypothesis, the first thing that you do is to state the hypothesis. So what is your now hypothesis? It's what? Yeah, so mu is, now the question says is at least, right? Mu says at least, which means as we believe that mu is greater or equal to what? To 0.25. This is the 25%. This one. Like in the alternative hypothesis, that's why you put sharp distinction. This is the now hypothesis. We're still in the now, but we're going to the alternative hypothesis, right? So how should our alternative hypothesis be? HA? How should the alternative hypothesis be? Is it? Yes. So mu is what? Is less than what? 0.25. You will not say less or equal to. So this person believes that the mu or not mu. This is the proportion, it's a percentage, sorry. You are supposed to use P naught, not mu. Sorry for that. You use P naught like this. Since it's not the mean, that's why they didn't say it's an average. It's a proportion, it's a percentage. You know that the way the proportion and percentage means the same, right? Okay, if you don't know, get it like that. So the way the proportion and the percentage means what? It means the same. So since it means the same, here you put what? You put the proportion. Okay. So you say in the now hypothesis, the first proportion is greater or equal to what? 0.25. Then in the alternative hypothesis, the proportion P naught should be less than what? 0.25. Is that clear? Is it clear here? Those guys who are online, are you fine? And are you able to see what we are writing?
I'm in a moving car, so it's bad. The network.
You are not getting what I'm saying?
Yes.
Okay. Are you able to hear us now?
Yes.
Okay. So are you able to follow the question that we are reading? We're doing question number 6 of the questions that we were doing yesterday.
All right.
Yes. So we are given, instead of the mu, the mean here, we are given the proportions, the percentages. Okay. So we are given that the first percentage, it is said that at least 25% of what? Of people, these are passengers, right? They buy some bananas before they reach where they are going. That is what is called the now proportion, not the now mean, like the now proportion, like the proportion that you get from the now hypothesis or the now claim. Is that clear? Did you get that? Leandro, did you get what we were saying? So I am just from saying that the way the at least means what? Greater or equal to. So that's why we are told that the proportion, the first proportion in the now is said to be at least 25%. So that's why we say the P naught is greater or equal to what? 0.25. Did you get that? Okay. Then the
Yes.
H naught, the alternative one shall be the what? Totally the opposite of the null hypothesis. So basically, that's the reason as why it became what? 0.25 lesser. Is that clear? Is it clear? Is it clear now? The second step is you compute the test what? Statistic. Statistic. Is that how we spell statistic? Statistic. Yeah. Statistic. Yeah. So now we said that yesterday we tackled two statistics, right? We did the Z statistic and we also talked about the T, though we never did an example. And we explained when you use those. But today we are introducing you to another statistic, the test statistic that we use. It's called the proportional statistic. Okay. So with the proportional statistic, again, it's just more like the Z statistic. You calculate the Z value, but using the proportion. You will not use you're not going to use the mu now. Yesterday you were using the mean, but now you're using the proportion. Is that clear? So it is said that Z shall be equal to P naught minus, not this P naught, is P star minus the P naught over the square root of P naught times 1 minus the P what? The P, how do I put the naught is P? Not all over the sample size, like this. So this is the formula.
Which one is which?
Did you get that? It's just a formula for computing the Z. If you've observed now, there are two proportions that have been introduced in the formula. There is this P naught, this first proportion that we have introduced, which is 25%, right? 0.25. There is another proportion. This one is called the sample proportion. Yesterday, you remember that we had the sample mean and the what? And the population mean, the mu. We used to have the X bar and the mu, right? So treat this one as the mu, just more like the mu. Then this one as the X bar. You get it? Now, but we are not talking about the mean. So we are talking about the proportion. So this one is called the sample proportion. Is that clear? So you need to calculate for a proportion from what? From the sample. So how do you do it? Let's gather data now. Let's gather data. What is our P naught? Our P naught is 0.25. Then to find the P hat, we call this as P hat. It has got some hat on top. It's called the P hat. To find the P hat, you just say the X variable, the individual variable that you're given in the question, all over the total sample size. Your M, you get that, right? The total sample size. Then that will give you the proportion. In the question says, what does the question say? The question gives all these things. It says, what is the proportion? It says that 18 out of what? Out of 60. Meaning your X is what? It's 18. So you're going to say 18, 1 over 80 out of what? 60 times 100 to make this proportion the P hat. Is that clear? So when they say that number out of that number, that is your X, that number over the total sample times 100, then it gives us the P hat. What is the P hat? Sorry? 30%? 30%. Okay, so which will be 0.30. You found that as well? Okay. Is that clear? Leandro, are you able to follow now? Okay. So I said that you need to compute the z. When you're computing the z using the proportion, you have p hat, which is the proportion from the what? From the sample. Then it minus the proportion that comes from the what? From the population, from the first claim. Okay. All over the square root of what? P naught, where the P naught is actually the population proportion. 1 minus the P naught all over the sample size. So we can substitute now the figures here. Fast forward. What is our P hat? Is 0.3. P hat is what? 0.30 minus what? 0.25 all over the square root of what is P naught? 0.25 times 1 minus 0.25 is 0.75, isn't it? Is that clear? Yes. You know how to do 0.75. You say 1 minus 0.25. You get 1 over 0.1. You get 0.25 times the 1 minus 0.25. You get 0.75, right? Then you divide that by what? By the sample size. And what is the sample size? 60, like that. Are you able to follow? Have I lost anyone up to this part? Did I lose anyone?
No, I'm behind.
Yes. Where is the question, madam? Exactly. Like you're very extremely behind.
Latest.
Okay. Question number 6 of the same questions that are at the end of the unit 5. So the question reads, and I'm sure you have that question. A long distance bus conductor claims that at least 25% of passengers, they buy bananas along the road before they reach where they are going. So yesterday I was bringing to light the concept of, hypothesis testing, that you need to be able to state your null hypothesis and your alternative hypothesis. So we said that it is given that in our question, the first proportion, which we term the P naught, right? The first proportion or the first percentage is 25%, which is 0.45. So when you are setting the hypothesis, we say the H naught then, or the null hypothesis shall be P naught will be greater or equal to 0.25, because the word that is being used there is the at least. We say that the word at least means greater or equal to. Then we say that the alternative hypothesis should be actually the opposite of that. Okay, so that's why we say the alternative hypothesis shall be P naught will be less than what? 0.25. Then from there, we compute the test statistic. Are you able to follow the questionnaire? Is the questionnaire able to follow now?
Yes, I am.
Yeah, we need to compute the z, just like yesterday. There is a z that we need to compute. But how do we compute the z using the proportion? This is the formula here that I've displayed. I've said it is p hat minus the p naught, okay? Over the square root of p naught, 1 minus p naught over the n, which is the sample size. So how do we calculate the p hat? That is the question, Miss P hat. We say it is basically given in the question that 18 people out of 60, they were able to buy. So this P hat is actually the proportion that comes from the sample. Okay, when they selected the sample of 60 people, then they had to analyze, and they discovered only 18 people were able to buy. Then you convert that 18 into percentage. You say 18 out of 60 times 100. It gave us the 30%. Then all the parameters being given, we just computed into the substituted. And as you substitute, you reach here. Are you okay now? Is the
Yes.
questionnaire okay or not? See you. Okay. What is 0.30 minus 0.25? 0.05 over, let's do this one. 0.25 times 0.75, 0.18 divided by 60, then square root the answer. What do you get? What the answer is what? You see? Okay, give me for this one. This one times that. Step by step. It's very important to move step by step. It is 0.80, 0.175. 0.1875 over 60, right? Then we square root. So can we do this divided by 60 and do the square root so that you can have 0. You have done even the square root. This is 0.007216. Okay. So can we divide now 0.05 divided by this so that we can get our z? What is our z? 6. We found 6. Okay. You also found 6? I said, what did you find out when you divided this into this? 0.1875 divided by 6. Or then just square root the answer. Say square root the answer so that we find what is here. You've done the same thing. 6.93. Just want to see if you are all getting the same thing. You guys who are online, what are you finding? Natasha, what are you finding? Or you are cooking also as well. You're in class at the same time you're cooking. What about the others who are calculating? What did you find as the final answer? You found?
I don't know if it's correct, but I'm finding 0.1052. I don't know if what I'm doing is the
Where down? Is it here?
yeah, no, as in the total number of everything.
Okay. Okay, do the final answer. We want to hear your final answer. As you said, you found it? 6.9 as well. You found it? 6.9. Okay. We have found here 6.9. That is what we have found from here.
Do everything.
Yes, when we do everything. We found our z to be equal to 6.9. Now listen, this z is a calculated what? Z. And it is given that we need to use, what is the significance level? It is given in the question. We need to use 5%, right? So it means our alpha will be equal to what? 0.05, right? The question specifies that use the significance level, which means our alpha, 5%, which is 0.05. Now, one thing that you should pay attention is that analyze, is this a double tail or a single tail from the question? Is it a single tail? I told you that we check from the alternative hypothesis. Is it a single tail or a double tail? It's a single tail, right? Hello? It's basically a single tail, isn't it? So it just shows that
Yes, sir.
all the data set is, yes, madam. We can hear you. Pieces of chocolate amazing. Well, maybe like you should throw them away. This one is very white. Yes, madam. What's your question? If you have observed, the alternative hypothesis HA has said that P naught is less than what? 0.25, which means all the data set is on the what? On the what? Yes. It's just one-sided. You understand, right? So this is just one-sided, okay? So if it is one-sided, it means that you don't divide this alpha by 2. That's how you are doing yesterday. Instead, you just pick it exactly the way how it is. Okay? So we are going to the what? To our table to look for the number, this one, 0.05. Okay? So 0.05 is somewhere here, right? It is in the alpha region. Then this side, we get the confidence level, which is 95%, isn't it? Right? Right? Yes. So this is 0.025. What you do, number one, just like yesterday, subtract it from 1. Say 1 minus 0.5. What number do you get? $0.91. 9550 something. So what you do, you go to that table, to the standard distribution, table, right? Standard normal distribution table. Yeah, that's how it is called. Standard normal distribution table. What do you get? You know the standard normal distribution table, like that one, the one that has this one, the one that is shaded all the sides. So we are looking for which number? We are looking for this number on that table. Which line is it? Well, I know. In the line of where do we find this number? It should be there. 0.950 something. We should have something that is similar to that, right? Let's take in the line 0.95 or something. I told you that even something that is close, like very close. Which line is it? Here it is 1.6, isn't it? Yes. In the line of 1.6 and what? 1.6 and 0. What? 0.4 and 0.5. You're following, right? Are you able to see where 0.04 is on top? Now, what you do is this. If you find that the number is an approximation, it is standing in between two numbers, you add those two numbers and divide by 2, get the average. Yes. Those guys who are online, are you able to follow? The two decimal places where this one is actually the one for 0.04, 1.6, one decimal place. Then on top, we have for 1.04 and for 1.05. Right? Yes. They are closer. So you add 0.6 0.9 what? 0.94, 0.9495, right? 0.9495 plus the next number is what? 0.995 05. You add the 2 and divide by 2. You get it, eh? What do you get when you get the average? What do you get? Sorry? 0.95. What about when you add the 0.04 plus 0.05 and divide by 2? 0.045. Where you round it off, like when you correct it to 2 decimal places, it would what? 0.05, isn't it? Are you able to follow? Yes. So it means you have 0.005, right? When you add all together, you have 1.64 or 65. Sorry. I know people are lost. I'm repeating this so that you are never lost. I know when you are lost from here. I can detect that you are lost now. I said that when you have those 2 numbers, right? These 2 numbers on top. The 2 numbers on top. What will happen is that those numbers actually approximate the number that you're looking for, that are nearby. You go upward on 2 decimal places, those. Add the 2 decimal places and divide by 2. Get the average of the 2 decimal places. You got it? Did you get it? Yeah, I get it. Did you get it? You got it? You got it? Those guys who are online, did you get it? So
Yes,
the
sir.
critical value therefore, okay, very good. The critical value therefore is what? 1.65. Okay. Our critical Z shall be what? 1.65 negative for this one, and the 1.65 for positive. Say. So, but we know that this data is rightly distributed. So we take this number which we have, the Z value that we have calculated is 6, right? I want to ask you from online, does 6.94 in the rejection region or acceptance region? Let me start from Natasha. Natasha, does the rejection, this Z value, our Z value, 6.9, or in the rejection region or acceptance region? I'm asking
I think
for online. Sorry? You said rejection, right? Okay, she's
yes,
saying
sir.
rejection. Okay. What about Leandro? Leandro, what do you think?
I think the rejection.
Rejection. What about here? What do you think? Correct. What do you think? Rejection region, right? If this is 6.9, it will be somewhere here, right? It will be a number which will be somewhere here in the what? In the rejection region. Therefore, how do you conclude this? We reject the what? The null hypothesis, which says that on average, the proportion is what? 25%, isn't it? You reject the null hypothesis, just make that conclusion, and you're done. But if you had found that this is Z, calculated Z is somewhere here, you would have failed to do what? To reject the null hypothesis, because this number would have fallen in the what? In the acceptance region. This failed to reject region. Is that clear now? Hello, those guys who are online, are you fine now? Are you better off? Are you able to do the questions on your own?
Yes.
Yeah, this one I'm taking time because it's the first one. The second one I'll close because I know that you'd have gotten the idea behind, isn't it? Yeah. Thank you so much for paying attention. Let's do the last example under proportions. I don't want you to fail any question under proportions. I don't expect you to come here complaining, no, the test was hard, D, what. No, I don't really expect you to do that. The second question, our second question is question number 7. Hilula, would you read the question for us or you are unable to see the question? Hilula.
I can't see the question.
Okay, like we are just doing those questions that we are kind of doing. Doing question number 7. It reads, last year I want you to state the null hypothesis. Yeah, so pay attention. The question reads, last year, 70% of total student applications received by GSD were from female. Did you get that? You got it?
Yes.
Then, out of a random sample of 150, what is the size of the sample? 150. 90 were from what? Female. I'm sure you've known the X already, isn't it? Test the hypothesis at the 10% significance level. Let's identify the parameters. First, let's set the null hypothesis. Let me start from the online, guys. What is the null hypothesis? Whoever can tell us the answer. Anyone? We are doing this fast since you already know what to do. So it is saying 70% of total students applicants received by GSD were what? Were female, isn't it? So we are on the X note, we are saying proportion P naught is what? Is equal to what? 0.70. You're following, right? And then the alternative one shall be P naught will be what? Not equal to what? 0.70. Because here we are using equal, right? They're saying is. They're not saying it is less than or greater than, right? Yeah. Are you following how we are moving? You guys who are online, are you able to follow?
Yes, sir.
Okay, you're good people. Let's compute the test statistics. As well, I told you that you compute a Z. Your Z is the P hat minus C, P naught all over the square root of P naught, 1 minus C, P naught all over N. So let's collect data again. Let's collect data. What is our P naught? .70. What is our P hat? Our P hat will be X over N. What is our X? We are told that 90 were what? We are female out of 150. So it will be 90 over 150 times 100. That is your P hat. What is your P hat? Hey guys, am I speaking so fast? Am I speaking so fast? Like you are unable to get anything? Lost? Have I lost anyone? No one is lost. People are following. So what's the proportion? 60%. Yeah. 0.60. You guys who are online, are you able to follow? And are you agreeing with us? Are you agreeing with us?
Yes.
The N is what? What is the sample size? It's 150, isn't it? The people, he selected the 150 women. 150 female, not women. From this, you don't have women, we have girls. Very beautiful ladies, right? And gentlemen. But therefore, we are focusing on ladies, our tough ladies. Okay, let's compute this. What do? We just substitute. What is our p hat? 0.60 minus c. Your p naught is what? 0.70 over. What's for p naught? 0.70, and when you say 1 minus 0.70, you have what? 0.30, right? Or over 1. This? Like 1 minus 0.70. You guys who are online, are you able to follow, or we are speeding too much now?
Can follow. I'm following.
Okay. Okay. Okay, now, so what do you get on top? You have negative 0.10, right? Over, down, let's do this one first so that we are not making mistakes. What is 0.70 times 0.3? 0.21, right? Over 150. What I want you to do is to say 0.21 divided by 150. 0.21 divided by 150. You find the answer, then you square root the answer. What do you find? Zero point what? 0.00. At 0 point what? Madam, you're welcome. I didn't get, sorry. 0.00. You have already square rooted. It's 0.2. 305. Okay, are you finding the same? Okay, so can you divide now? What do you find as your z? It's negative what? What is your z? Negative what? Negative 32. What do you find? You guys who are online, what do you find? Anyone can tell us the answer over here. Negative
73. 32.
Negative 73. Okay.
Negative 32.
Oh, negative 32.
Yes.
I've received 2 answers. You guys are saying, someone is saying negative 32. Right?
Yes. Yes.
No decimal places. 0.733. Okay, 0.73. Right? Okay, you have computed your z. You're following, right? The one that comes from the proportion. So what you need to do, you are given the significance level to be what? What's the significance level? 10, which is the same as 0.10. But when you look at this, we say this is what? Is this a single-tailed or double-tailed? What is this? It's double-tailed, right? So you divide your alpha by what? By 2. Divide this by 2. What is your alpha over 2? 0.05 again. Since you're using the standard, the cumulative standard normal distribution table, the cumulative one, you say 1 minus what? 0.05. What do you get? 0.95, isn't it? Can add from 0. Then again, if you observe, this is leading us to the same solution that we had in the previous exam. If you observe, it's basically the same, right? The critical value is the same. Yeah. You go to get the critical value. What do you get as the critical value? Yeah. You just go to the table and look for this number. Then you move to the left. get one decimal place. You said you found 1 point what? That was 1.6, isn't it? 1.60 plus the top two. It was 0.04 and 0.05. You added them, got the average. That gave you what? 0.05. You added, you found what? What did you find? 1.6 what? 65. Isn't it? Okay, let me hear it from those guys who are online. Is there anyone that we have lost from online?
Sir, how did we find the 1.6?
1.6. Okay. Are you able to locate this number or a number that is similar, that is closer to this on the table, on that standard normal distribution table? That one which is shaded from this side, like all the way from this side up to somewhere. Are you able to locate
Yes,
it?
I found it.
Actually, it is not the exact, you have located it. It is not exactly
Yes,
it's not the exact figure, actually. It's something closer. There are two numbers that are closer, isn't it? So you take the average of the two decimal places on top. Are you following? In the line of 1.6, if you follow to the right, you find some number like the 0.94. The other one is 0.94 something, isn't it? 0.9445.
Yes, sir.
Then the next one is 0.95 something. Then 0.9405. You add them. You add those two numbers on top, like the two decimal places. Yeah. You add them and divide them by 2. You find 0.05. Then that's how you add and you get the critical Z. Is that okay? Our colleague online was asking how we find the critical Z. Are you fine now?
Yes, I'm okay.
Okay, if you are okay now, so it means that our table will be like this one. Let's visualize. It will be something like this: 1.65 and what? Negative 1.65. Then when you take this Z value of yours, is it in the rejection region or acceptance region? It is in the it's in the rejection region, isn't it? Right? Have you gone with the same conclusion with you guys who are online?
Yes.
Yes, negative 32 will be somewhere here in the rejection region. So we reject the what? The null hypothesis. Is that clear now? Hello?
Yes, sir.
Is that okay? Yeah. So this time around, I want to ask you for questions.